welcome. Today we're going to be looking at backgrounds, and not just backgrounds that you can see, but also backgrounds that give light, HDRI. HDRIs have 32 bits of light data, which means that you can have extremely bright lights, for example the sun, all the way down to blackness, and it also gives you 360 degrees in all directions, and it gives a much more natural lighting. So to start with, you can see our Coke can here, our pop can, and the background right now is this magic texture. The magic texture is here. I won't be using that in my final product, but I put it in so that you can see that this is the background. And if I increase the brightness of the background here to like 100, you can see that it hasn't changed the shadow or the lighting on the geometry. It's only the background color, the picture. Whereas this one here is the light itself. You don't see it, but it's the light. So if I put this one back down to 0.1, so it's almost black, you can see it's not giving any light. This one's at 2. If I put it up to 100, it's going to blow out the lights. And you can see it's not lighting the background image. It is only lighting the geometry, the Blender geometry. So in this way, I'm going to get rid of this magic texture because we don't really need it. I just put it in for show. And I'm going to actually feed in my background image into the color. And I want that to be lit a little bit, so I'm going to bring it up to about 2. I think should do the trick. Nah, a little brighter than that. Let's make it 10. Yeah, not too bad. You can see that the background is not in the position we want. You can see the studio lights and the studio backdrop, and we're looking through the camera. So to fix this, we come down here to the rotation. We rotate on the Z. You can see the background rotates. So I'm just going to rotate this until I get right in the middle. And now the shadow that you saw before, and again it's too bright, we're going to turn on these lights so you can see the shadow a lot better. As we rotate, you can see that the shadow moves. It's an important concept. And if we go all the way around, you can see where the light is coming from. There's the studio light with a studio reflector underneath. It's a very good setup to light a face, for example. So in addition to this nice white background, this black table here, I also want the water droplets on the can to sparkle. So I've added in some lights. I'll turn them on now. And this view is the top-down view, number 7 on the keypad. And you can see here's the camera looking in, and now I've got 2 basically rim lights and 1 from the front, which gives this a really nice lighting and a little bit of interesting light play on the table. So the only thing I guess I didn't explain here is the light path is camera ray. So if it's going to the camera from the objects, then it'll pick one shader, and if it's not, it'll pick the other shader. That's how this mix shader is choosing which thing to show to the camera. Oh yeah, the image I'm using is from these guys. Here's the image. It's free. It's a great place to get free images. I'm using the 1K image. I tried before using, I think it was the 4K image, and that image is so large that it just bogs my computer down. I can barely move, can't do anything. So I found that this image is good enough. I just have a white background and the light looks good, the shadows are sharp. If I increase the amount of K, then we would get slightly sharper shadows, you'd get a better background look. But for us, 1K is plenty, it works great. I also was doing some research. Get rid of this guy. Put him over here. And this guy's website is really good. He gets into some great detail about how to set up these node maps. And this guy took the first guy's information and did something even better. So I'd recommend you read these two. if you really want to know inside and out how to use HDRI lighting, it certainly will make most of your images look better if you do it. So the next thing, I'm using textures.com's Grunge Maps 0043. Got the idea from Blender Guru, and it works pretty well. This is the one we're using here. It's also free, so no need to worry about paying for it. And as you can see, it's on the Coke can. Right now we're in world mode. I'm going to go to object mode. And now the selected object is what we're going to have for our map. And here you can see I'm doing the same thing to control rotation and orientation of this grunge map here in the background and this sticker. This Rocket Cola is the sticker that's on top here, and this is just a flat 2D image I made with Krita and downloaded the rocket picture from a CC0 website. Added some texture to it, as you can see here. I'm going to switch to Eevee so we don't have this look, this changing in look all the time. And you can see I also applied the same grunge map to the tabletop. And if you look really closely, it's hard to see, but there are water droplets here inside the Coke can. Those are from my original image I used to get the shape of the can. And it's this empty here. I'm going to turn it off for the render, for the viewing, and for touching. So now there are no more water drops inside the can. Just our nice shiny can with its water droplets. So I think this part is pretty easy. You just adjust your scale, and like you can see, for example, here I'll adjust the scale. I'll make it, we have 0.38, I'll make it 0.9, and you get a huge rocket that's off to the side. And you just play around with this number until you get the number that makes it look good. In the same way, this 4:7 I can use to rotate it around. And you just put it where you need it to be. Fairly easy. I'm using UV coordinates. This can is automatically UV unwrapped because I started with a cylinder, as you saw in part 1 of the video. And the same idea here. I've scaled the grunge map. It's on non-color data, that's important. Oh, this is also on extend instead of repeat. If I put it on repeat, then you'll get cans top and bottom and going all over the place. So I just put it on extend. We just use one image here. Here it's repeated because I don't want the texture to end. And I think it's a seamless texture, I'm not sure, but in any case it works. So then we take the color data, and first of all I'm going into the height map. It's, you can see it's 0.209 and 0.010 for the distance, and that's going into your normal map. And that tells it how big these bumps should look from the texture. The other thing that's going on is the roughness. The roughness, it determines how shiny the can is, and when there's water on a can, it makes the surface really smooth. And when there's no water, it should be more like this matte finish on an aluminum can. And these two numbers, each one of these positions here indicate a number, which is roughly the roughness. So if I go here and I switch this from, well, it's right in line with this line. I just want to make sure I get right back to the place I had it on. You can see how it changes the shininess in the background. And then if I click on this, I already did that one. Click on this number, which is pure white, it'll change this one's shininess. You can see how that changes there. And it's really just a matter of playing with it until you get what you think looks good. You know, like that might be better for floor. For what I want, this looks good. And again, these also just determine how big these stripes are, like where the cutoff is. So if I take this and I move its position it's at 416. If I move it, you can see how it changes the look. And same thing with this one. You'll see how it changes, how much that grunge map is being represented. And it's really just a matter of backing off and looking at it. Does it look like a wet can to you? If it does, then everything's good. Right now, maybe it looks a little shiny to me. So I might come in here and adjust it. Make it a little better. Yeah, looks better to me. Okay, and then for the table, I basically did the exact same thing. Color ramps, bump map. I didn't have to input UV for this. It's obvious to the computer that this is a flat surface. Nothing needing to be unwrapped. And I just did this to make the surface a little less boring. So, the next thing we want to look at are the water droplets. And I've pre-worked the water droplets, so they're in collections. And a collection is kind of like a layer in the old Blender. They're now called collections, and you group things by collections. To make a collection, you just right-click, make new, and then you can start moving these things into your new collections. And what I have here is a bunch of spheres that I made, and you can see them in the image. Here is one bunch of spheres. And this sphere is a very special one. I made it this way on purpose so that it's very directional. You can see which way it's pointing. And the other spheres are little teeny dots, which are here. If you look at a can with water on it, you'll see that most of it is little teeny tiny droplets, and they're almost all spherical. And then there's a few big blobby looking drops where they've merged together and so forth. In the final render, we don't want to see these droplets. So they will be, you click on this camera on the collection here, and that will make them invisible to the render. Right now we want to be, and then we can make them invisible to us. You can turn them on and off. And the other thing is that I used a glass shader. 1.333 is the refraction for water, and I give them a little bit of roughness so they're not too crazy shiny. It looks a little better on the render, I feel, although water might be perfectly shiny. And I gave them just, you can't really see it, but they're just slightly blue. And again, I did that just to give a little more visual interest. And you're wondering why we can't see them here. The reason is because we've got to go to particle settings. I spent a lot of time working out how particle systems actually work. First we got to select the can, then we go down to particle systems. They're not very obvious. I almost feel like blender.org could make emitters, hair, and surface objects or something like that. But the way it is now, we just use the hair when we want to put things on the surface of something. And so I'm going to turn on my particles so they can be seen. So now they're all there, and you can see I've got lots of particles. And they look kind of crazy. So I'm going to turn off the small water droplets so you can see just the big water droplets. And as you can see, they're all pointing roughly upwards. In order to get what we have here, you click on Advanced, and we put the number of particles. I've got it set to 1,000. The seed number is, in computers, when you do a random number, it's really a pseudo-random number. And the computer just generates a list. And every time it'll use the exact same list. Even though the numbers appear to be random in the list itself is always the same. If you want to change the list, you have to change this number, which will change the random numbers. And if I do that, these will all move to new random locations. For us at this point, it's not very important, although if you look at your water droplet and you think, man, I don't want that water droplet right there, it looks really stupid, you can just adjust this and all of a sudden you'll get different places for the water droplets. There's no predicting what's going to come or why, but you can play with it and just find what you like. I'm perfectly happy with water droplets where they are, so I'm not going to bother with it. Segments makes absolutely no difference. Ignore it. This is where the faces, or where the particles come out, if they come out from the face. You can also come out from the verts or from the volume if you want them in the air around something. We don't want that. I'm using the modifier stack, so it gets my subsurface. I've chosen distribution random instead of jittered. It's just, I feel random looks better, but you can play with it. There's nothing sacred about it. I want a random distribution. I want the distribution to be even. So, the next thing here, normally a lot of people will just start with velocity, but I think what's really important is to first understand that we're working with normal and not normal and tangent. Only normal. So up here, all these things that say tangent, they will not do anything. If I change the numbers, it doesn't change anything about it. Well, it does actually, it's changing the size. But in any case, just leave them at 0, ignore them. The hair length, I forgot the hair length up here. The hair length determines how big the particles are. It's like the initial size. So if I make that smaller, you get smaller particles. I want the particles big so you guys can see them. So I'm putting that on 10. This is also determining how big the particles are. If I make this number bigger, I'll get bigger particles. This randomize will randomize the size of the particles. It also makes them bigger. So it's important to randomize them a bit. You can see this doesn't do anything. It's an unimportant number. That's why it's on 0. Okay, so to sum that all up, hair length and normal determine size. The randomness will also give them a random velocity, which will give you some random size of your particles. So I'm going to shut that. So the next thing is rotation. We're only rotating about the normal. And actually I found that I really don't like much rotation on it. So to start with, if we put the phase to 0 and we put the random phase to 0, all the particles are shooting straight up. And that's why I put these axes on here. The other thing that's important to realize is that if we go into the can, you can see on the inside of the can, you're getting the other side of the particle. So you're only seeing half of what you design. So that means that anything on, I believe it was the x-axis, I have to go back and look again, greater than 0 is going to be on this side, and anything less than 0 will be on the other side. Might have been the other axis. Doesn't really matter, you can play with it, you'll see for yourself. Just be aware of that, you're only getting half the particle. So if I had taken this point and pushed it back, it would disappear somewhere around here. So I want to keep everything that I want viewed on the plus side of that axis. So if we randomize it, see it chooses random strange positions, which isn't good. We don't want the points of the tips of them coming off, although you might. If your spheres are kind of randomly shaped and they're not big points like mine are, then you might be okay with that coming off and giving you some different shaped particles because the other half of the particle is submerged. But I want it at 0. Phase is your rotation. And you can see how it rotates like that. If this is at 0, the random phase only goes one direction, more or less. You can see none of these particles have gone off in this direction. So if you want them a little bit right and a little bit left of straight up, you actually have to set this to 0. We actually have to rotate these backwards a little bit, wrong way, back a little bit, and then when we do this a little, you'll start getting some of these little suckers that are forwards and backwards around that middle point. Okay, so that's it for the position of the particles on the can. The next thing is in render here, we want to use collection. And as you see, here's collection 1, collection 2, or collection 3. I erased collection 2. And these are all my particles. Again, you can pick the scale and how much the scale is randomized. And here we open up this, and we have collection 1. Yeah, and I'm picking random. That's important. It means out of all of these objects, it randomly picks an object and puts it on the can. Randomly picks another object, puts it on the can. And use count, it's not only using this list, but it's using a duplicate of the list with duplicates of the particle. For example, sphere 3, sphere 3. It's the same thing happening many times. So that means that maybe I really want to use a whole lot of sphere 003, but I don't want to use so many of these pointy things. So I could take all of the pointy things out of here, save 1, and put a whole bunch of the other ones in here, and so I would have a lot less pointy ones showing up on my can. It's a way to control how much or what percentage of each object in your collection appears on the can. The next thing that's important, children aren't important, we get that, is, that's okay, I'll leave that, vertex group. Vertex group density controls how many of these sphere objects from the collection appear on what surfaces. If you look at the top, yeah, it looks like a mess, but we don't care because it's not in our picture, or the bottom, you'll see there's no water droplets there. And that's because I've selected the can, I've gone into edit mode, and you can see where the orange part, I've only selected these planes, and this triangle here is where you define a group. You select everything that you want in your group, and you click assign, and it assigns it to this group. So then when you're in particles, you can come here and you can pick what group. I only have one group, so that's what's picked. You can also use it to control all of these other variables. So you could have different roughnesses or twists, whatever. All sorts of things can be controlled with groups. And you can also come over here and move this over. If we click on weight paint, let's see, it's been a while since I used weight paint. Here we go, weight paint. You can see where it's red is going to be using lots and lots of particles. As it moves to blue, it uses no particles. So there's a small chance of a particle here on this green part and lots of chance on the red part. And you can actually take your paintbrush and paint this. So you can choose where you want more water, where you want less. For example, if you didn't want any of these particles around your logo, you could paint the whole logo blue here. And then you wouldn't have any particles appearing where the logo was. So, what else is there to tell you? I also have the small water droplets. You can see there's a whole lot of them. Go back to object mode. And yeah, I forgot to tell you about the water droplets texture. They have a glass shader. They also have an emission shader. and I'm mixing that in a little bit, just a little bit of emission. So that means each one of these water droplets will glow. And with that light in the compositor, I can add a little star shape, a little water droplet stars. It'll make it look sparkly, which is why I added just a little bit of emission. So yeah, the next step is going to be the compositor, but I'm going to make that into tutorial number 3. If you have any questions, please ask me. Be sure to sign up on YouTube and click the bell. And I've yet to get my first patron. It's very important to me. Obviously, I want to make some money with this. So if you're enjoying the videos, I'd love it if you'd sign up there. Even if you just give me €1 per video. You know, I've had 400 views on one video. If I had 400 euros from those 400 views, I'd be quite happy. Thank you for your time. And like I said, if you have questions, ask me. I'm available on Facebook. You can talk to me on YouTube. You can even email me. And I also have quite a few groups on Facebook, so you can check out those groups. Thanks. Have a good day.